Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, I will start to discuss some of the tutorial questions. I want to pick only few code, not all the questions. Okay, we're going to start with question number 7. So question number 7, the question wanted to determine the magnitude and direction of the magnetic field at point Q. So point Q is over here. Due to current I equals to 1 ampere. So let's say you have a current I equals to 1 ampere over here, flowing in a semicircle wire with radius R equals to 2 centimeter as shown in figure 4.2. So R is actually equals to 2 cm. So this is the question. So just label it over here and taking out the information. Okay, so actually if you look carefully, you can divide this diagram into 3 sources of magnetic field: AB, BC and CD. So for AB and CD, it is actually due to long straight wire. But if you guys still remember, when you try to determine direction of magnetic field, you will see that magnetic field produced is actually over here on the side of the wire itself. Okay, so if you have the position is at Q, actually AB and CD produce zero magnetic field at point Q. So I can write here as B due to AB plus B due to CD is equals to 0. So obviously you still have BC over there. So for BC, magnetic field produced is actually due to circular coil. So if you guys still remember, the formula for circular coil is mu naught I over 2R. Okay, but here this is not a complete circle, but instead it is a semicircle. So you just have to divide that one by 2. So that one is kind of logic lah. That one is only half of a circle. So to solve that one, you can simply substitute all the values inside there. Okay. So maybe I can rewrite here as sum of B net at M, ataupun maybe I just write as B at M, Q. B at Q is equals to BAB plus BCD plus BBC. But the first two here is equals to 0. So you left with BBC. And BBC is actually half mu naught I over 2R. So mu naught is 4 pi times 10 negative 7 multiply with the current 1 ampere, and you have radius of 2 centimeter. I have to change to meter, okay, because you have a constant over there. So now you just have to press your calculator correctly. I got here is 1.57 times 10 negative 5 Tesla. So obviously if you have multiple source of magnetic field, you have to consider the vector and direction. Okay, but here you notice that the other two is equals to 0. So the one that important here is the direction of magnetic field due to BC. So you can use right hand grip rule. Okay, and you will see that BQ is actually out of the page. So if you put your fingers over here like this, right, this is your finger like that, so your thumb is actually pointing out of the page. Okay. Okay, moving on to the next question, which is question number 9. Actually, question number 9 consists of question A, B, C. That one I think is just a comparison between magnetic field and electric field. I think you can do it yourself, okay? If you're not sure, you can always ask me. Okay, for question number 9D, a helium ion of a charge positive 2 electron and a mass of 6.6 times 10 to the 4 of negative 27 kilogram is accelerated by a voltage of 2400 volt. The accelerated ion then moves into a perpendicular uniform magnetic field of the magnitude 0.24 Tesla. Determine the radius of the circular path of the helium ion. So if you want to calculate D, question number 1, you want to calculate the radius. So if you want to calculate the radius of the circular path, so you can start with FB equals to FC. Force due to magnetic field is equals to centripetal force. So that one is equals to mv squared over r, and this one is actually equals to okay, but if you want to find the values of r here, you need the values of q, b, and most importantly you still need the v. Okay, v here you don't know, so you have to calculate. So to calculate values of v, you can use, maybe I can write over here. You can use, this is velocity, v here stand for velocity. You can use conservation of energy, where potential energy is equals to kinetic energy. So potential energy for charge you can represent by Q multiplied with V, which is equals to, this one is capital V, half mv squared. Okay, so my V here, velocity, is equals to 2qv divided by m. Take the square root of that thing. Okay, so I'm going to write this one a little bit smaller so that you can differentiate between velocity and potential. Now you just have to substitute the value. V equals to, I think I'm going to have to bring this one to the left a little bit. Take the square root of everything. 2 multiplied with the charge here is 1.6, but remember the charge here is positive 2 electron over here, so you still have to multiply by 2, and then with 1.6 times 10 negative 19. The voltage here is 2400. I think you need to be familiar with this formula, because sometimes you still have to use it. The mass is actually equals to 6.6 times 10 negative 27. Okay, when you press your calculator, make sure you take the square root as well. Okay, here my velocity that I got is actually equals to 4.82 times 10 to the power of 5 meter per second. Okay, so actually you need to calculate this one first. Maybe I can put this one as my first step. Okay, and the second step is actually to use the equation of circular motion to solve the values of R. So R here is actually equals to mv divided by qb. So the mass, again, you just have to substitute the value, 6.6 times 10 to the power negative 27. The velocity is the one that we calculated just now, 4.82 times 10 to the power of 5. And then the charge here is 2e. So 2 multiplied with 1.6 times 10 negative 19. And the magnetic field is 0.24 Tesla. Again, just take your calculator and you should get the answer. Here I got 0.04. Okay, so this would be the answer for question number D1. Question number D2, they want to find the period of revolution of the helium ion. So this one I think you can use kinematic of linear motion per equation. If you guys remember, V equals to question number 9, D2. You know that V is equals to S divided by the time, kan? But if we are talking about the one complete circle, it will be 2 pi r divided by the period. So you want to find the period. So T is equals to 2 pi r divided by the V. The radius you got it just now, 0.04. And the velocity is actually equals to 4.82. So I got here is 5.21 times 10 negative 7 second. So very quick circular motion here.